Hello, grade 12. Welcome back to the channel. In today's lesson, we're going to be looking at physical properties, and we are tackling question 3 prelim from Gauteng 2022. And let's get right into the question. Now 3.1 says study the following two organic structures and answer the questions that follow. We are given compound A here, and we can tell from the formal group here that this belongs in the aldehyde homologous series, right? So we can say the double bond oxygen is attached to the first carbon. Then we are given compound B, which we can tell from this carbonyl group here that this belongs in the ketone homologous series. We can see the double bond oxygen is attached to the carbon that is attached to two other carbon atoms, right? Now 3.1.1 says compound A and B are functional isomers. Define the term functional iso. Now we say functional isomers are organic compounds with the same molecular formula but belong in different homologous series and have different functional groups. 3.1.2 says write down the IUPAC name of compound B. So now in order to write down the IUPAC name, we first need to count the number of carbons in the parent chain. So we have 1, 2, 3, 4, 5. We know that's pent, right? But since this belongs in the ketone homologous series, this is pentanone. But remember also we need to indicate the position in which the functional group is occurring. So the functional group, we have it in carbon number 3. So naming this one, we will have pentanthreone, right? Now 3.1.3 says, how does the boiling point of A compare to that of pentan 1-ol? Write down only greater than, equal to, or lower than. Now looking at A, we have already identified that this is an aldehyde. Now what are the intermolecular forces present in this aldehyde? We know it's the dipole-dipole forces. Now dipole-dipole forces are weaker than the intermolecular forces that we find in pentan 1-ol, which are hydrogen bonds, right? So we know if we have weaker intermolecular forces, we have what? A lower boiling point. So the answer is it has lower than. The boiling point is lower than. Now 3.1.4 says explain your answer to question 3.1.3 fully by referring to the type of intermolecular forces present in each of these compounds. Now for this one, we're going to use the method ISE, right? Where we said I is where you identify the intermolecular forces present in those compounds, and then S is where you speak of the strength of the intermolecular forces. You compare the strength of the intermolecular forces, and E, you speak of the energy required to overcome those intermolecular forces. Now starting off, we'll say pentan 1-ol has hydrogen bonds and pentanal compound A has dipole-dipole forces. Now dipole-dipole forces are weaker than the hydrogen bonds. Therefore, less energy will be required to overcome the intermolecular forces in pentanal than in pentan 1-ol. Thus, the boiling point of pentanal is lower than that of pentan 1-ol. Now 3.1.5 says, how will the vapor pressure of compound B compare to that of pentan 1-ol? Write down only higher than, lower than, or equal to. Explain the answer fully. Now, if we are comparing this pentan 1-ol, an alcohol, with compound B, which is a ketone, what are the intermolecular forces in the ketone there, compound B? We know that they are also dipole-dipole forces. Now, dipole-dipole forces are weaker than the hydrogen bonds. Now, we know also the weaker the intermolecular forces, the higher the vapor pressure, because intermolecular forces are inversely proportional to the vapor pressure. So the solution is higher than. And explaining that, we say pentan 3-on, which is compound B, has dipole-dipole forces, and pentan 1-ol has hydrogen bonds. Now, dipole-dipole forces are weaker than the hydrogen bonds. Therefore, less energy will be required to overcome the intermolecular forces in compound B than in pentan 1-ol. Thus, compound B will have a higher vapor pressure than pentan 1-ol. Now, coming to 3.2, it says, learners use compounds C to E to investigate one factor which influences the boiling point of organic compounds. Right. Now, when we observe this one from C all the way down to E, we can see that here the chain length is increasing, right? So we are adding more numbers of carbon and hydrogen atoms, right? Therefore, the chain length increases and also the molecular mass. And then as a result, also the surface area is becoming what? Larger, right? Then when we observe in this column, we can see that the boiling points are also what? Increasing, which we can see that we are seeing a direct proportion relationship there. Now 3.2.1 says define the term boiling point. Now we say boiling point is the temperature at which the vapor pressure of a substance is equal to the atmospheric pressure. 3.2.2 says write down the independent variable for this investigation. Now you will remember that the independent variables are the factors that influence the physical properties, right? So when we speak of your chain length, your molecular mass, your surface area, the number of branches, or the type of intermolecular forces, these are the factors that can influence the physical properties of the organic compounds. Those are your independent variables. Then the dependent variables are the physical properties themselves. So you have your vapor pressure there, you have your boiling point, you have your melting point, and your viscosity. Now here we want to see that one factor that is influencing the boiling point here. What is it? We have already mentioned it. It is the chain length, right? So chain length, molecular size, or the surface area is that one factor that is influencing the boiling point of this organic compound. 3.2.3 says, write down the type of van der Waals forces that occurs between these organic compounds. Now we can see that these compounds are what? Alkanes, right? They belong in the homologous series alkane because of single bonds between carbon atoms, single bonds between carbon atoms. So if you can observe that condensed formula, you can see that there are no double bonds, there are no triple bonds. These are only single bonds between carbon atoms, which we can say that these compounds belong in the alkane homologous series. Now, what are the intermolecular forces in the alkane homologous series? We say they are London forces. Now 3.2.4 says write down the conclusion that can be drawn about the boiling point of straight chain alkanes. So what can we say about the boiling point of straight chain alkanes? Now we can observe that here. We can say that the boiling point increases with an increase in the chain length. So the longer the chain length, the higher the boiling point. Awesome.